So guys, when x equals 0 and we sub that in, we get y equals log 0 cubed, which just gives us log 0, right? Let's see why we get an error for that. So if we have y equals log 0, remember the base is assumed to be 10. 10 to the power of y equals 0. Is there any value of y that we could replace as an exponent to make 0? No, we get an error. Okay, so that's why we have an asymptote at x equals 0, because there's an error there. So this graph is approaching the y-axis, or vertical asymptote, x equals 0. So if you ever need to build a graph, you just have to plug in your x-coordinates into the actual logarithm. And if we proceeded with putting in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on, so on, so on, we would get this shape. Okay, for all positive values of x. Now let's compare that graph to y equals 3 times log x. So take note of some of these values in the table here. Okay, at 1 we have 0, 2 we have 0.9. Let's see what happens when we put in the second graph, which will be 3 log x. Okay, I'll go to my table of values. What do you guys notice is occurring? They're the exact same. Okay, that graph and this graph are identical. They're exactly the same. And even if I took y1 away, you would see it gives the exact same graph. Alright, so in the case where our n value is odd, what can we say about the two graphs? We have the same graphs. Okay, where x can't be 0 or anything negative. We get error, 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 error. Yeah, which gives us our domain, right? Like x is greater than 0 here, x is greater than 0 here. Now we're going to investigate the even case. Is it alright if I erase this? I guess so, okay? So the even case is when n is equal to 2, 4, 6, 8. In this case, let's just study n equals 2. So in your calculator, could you guys put y equals log x squared? Okay, and then we'll graph it. Whoa. This is what we want to see. Jane thinks it's cute. Okay, I'm just going to zoom in because I want to just see something a little bit closer. Whoops, zoom. 2. Do you guys think those graphs are approaching a certain line?
No.
Or do you think it's going to touch?
It's not going to touch.
Not going to touch? Well, let's just check it out. Go to our table of values. Where do you see an error? At x equals 0.
So it doesn't touch or it does touch?
And let's just talk about the table of values first. So at -3, if we plug that in, we get log, -3 squared is actually like log 9. And that is equal to, in our table of values, I didn't go high enough. We evaluated log -3 squared, we would get 0.95. Okay, when we plug in negative 2 squared is 4, so we get log 4. That equals 0.60. When we sub in negative 1, again, squaring a negative number gives us positive, so that's like evaluating log 1. And we get 0. When x is 0, log 0, does that exist? No, we have an error. Okay, and this error is where a vertical asymptote is going to exist at x equals 0.
So it does touch the
It doesn't. A vertical asymptote is telling us that the graph is approaching that line, but it's not touching. Okay, let's carry on. When we sub in x is 1, okay, we get y equals log 1 squared, which is just log 1. Have we already calculated that? Yeah, it's equal to 0. So when x is negative 1 and x is positive 1, our y value is 0. These are our x-intercepts. Okay, if we carried on subbing in x equals 2, that's equivalent to log 4. 2 squared is 4. That gives us 0.6. Do you guys think these values are mirroring each other? Yeah. When we can check out the table of values, we can see that they're exactly the same. Great, now let's compare that graph to y equals 2 times log x. And actually, before we even graph it, let's just get rid of this for a second. Let's look at our table of values. And I'm pretty sure we'll be able to start with negative 3 and fill in the rest pretty quickly. If we sub in negative 3 for our x, we get 2 times logarithm, negative 3. Do you guys remember if we're allowed to take negative logarithms? No. So 2 times something that doesn't exist still doesn't exist. We have an error. Okay, what about 2 times log negative 2? If we have a negative logarithm, does it exist? No. Okay, and we're going to have an error for negative 1. What about log 0? Does that exist? Nope. So anything negative, including 0, won't exist. Okay, let's calculate 2 times log 1. What do you guys get? Put it in your calculator. 26 now? Okay, what about 2 times log 2?
I lied, sorry.
Yeah,
1
I
0.
got 0.
1 0. So
That's right.
two.
Number
That's
2 is 0.6. Yeah, good. That makes more sense. Now 2 times log 3, is it 0.95? Good. What do you guys notice about these values compared to these values?
Similar.
They're exactly the same. Now let's graph it just to prove it. So they had a bit of fun in math.
Yeah,
Of course that's why. Okay, so 2 log x. Plug that in. Let's see what that looks like. It's only one side. And why is that? Because we have all these errors at 0 and anything negative. So I think it's useful to draw this graph. Just clear that out. Okay, where are we approaching?
Y
What's this line?
axis. X equals 0.
0.
The y-axis, which is the equation x equals 0. That is our vertical asymptote. Good. And anything positive will exist, anything negative won't exist. So one thing we can conclude is that for even exponents or coefficients n, okay, we have 2 different graphs. If it's x squared, there's two pieces where we have a vertical asymptote, x equals 0. But if we just have a single logarithm where it's not squared, then we only have one piece, because negative logarithms don't exist and 0 logarithms doesn't exist. Cool?